Hello, welcome to this Python Pandas tutorial. We're going to be going over some techniques, some EDA techniques, practical group by patterns, cleaning data pipelines with pipe, feature engineering, some hierarchical indexing, and machine learning prep. So basically, we're going to be working with this TIPS data set. It comes from seaborn. So load that up. And while we're loading, you could see that basically this df info gives you the variable, whether it's non-null, the data type, float, category, and integer. Okay. Could use df describe to do some exploratory data analysis. And this is for mostly continuous variables or numerical columns. You're not going to be able to use this with categories. So we could see kind of the distribution, the 20th, 50th, the median, the 75th, the max, mean. And obviously, I mean, just looking at this data set, it's a TIPS data set. Um, the total bill is probably going to be higher than the tip, right? The average. And this is the size of the party. We already saw that it's non-null, but this is a common check to check like how many nulls there are as a percentage. We could see that it's obviously zero. We saw that it's all non-null. So I know it's redundant information, but this gives you kind of a good sense of like what is missing or not. Now, I mean, like we're going to actually look at the structure of the data set. We got this total bill, tip, sex, smoker, day that these people came in, the time, and the size of the party. Now, sex is a categorical value, obviously. We've got more males than females here. Okay. So that will skew the population in favor of males, right? So we wouldn't be able to do like what's the word? Like a kind of like equal, we don't have an equal analysis here. Okay. Here's smoker. And obviously it's skewed towards people that don't smoke. The type of days, Saturday, Sunday, Thursday, Friday. So you see Monday, Tuesday, Wednesday is missing. So it's probably referencing that it's open these days. We could also do two variables and build a multi-index around that. Okay, so I do it around day and time, and you sort index. Okay, so it goes from Thursday to Sunday, and then lunch and dinner. And Thursday, I mean, you could see that lunch is it's way higher than the amount of dinners. And then on Saturday, dinner, there's no lunch. Sunday, dinner, Sunday, six. These are pretty high numbers relative to the rest of the times. Now with continuous values, we saw these discrete values that we could express it as bar plots. For continuous values, we could actually express the KDE, the kernel density. Okay. And this is the total bill. So we look at it. I mean, most of it falls between 20, right? I would say 20. This is here is basically zero. Okay, so I mean, like obviously we're not going to have total bills that are negative 20. The graph is scaled this way so that it could show the plot from a more holistic perspective. Okay, and then you've got some a kink here, right? This is zero here, but we've got a kink here saying that the total bill is a little bit higher, like 50, 60, something like along those lines. We could check the max again for the total bill just to make sure that the graph is making sense. And it's 50.81. Okay, so looking at that, going back, you could see the kink here, 50.81, and it just flattens out at 0. 60, it doesn't exist. Obviously, like I was mentioning earlier, it's just drawn to scale to make the graph look presentable. Now we could do it for tip as well. Okay, and we see that most of it falls between 2.5, right? Again, there's a kink here, and then it flattens out to 0. Okay, and obviously we can't have negative tips here. So that's a kernel density, and it's used mostly for continuous values or numerical values, whereas in categorical, the values are discrete. Okay, we count them. Here we go on to some data manipulation, which is important process in the data processing pipeline. So we could take a subset here. Okay, let me just go back. So I actually did run this df head. Okay. So we could filter this, and something else I'd like to show you is basically that that's a Boolean, or it should be. So you're going to see this Boolean here, and then this df. If it's true, then it's going to take that subset, okay? If it's false, if it's false, it's not going to take it. Okay, so you could see that checking after processing, there's 176 rows. That's something to keep in mind. When you're processing data, you might want to do some accounting in terms of how many records were dropped or whatnot, how much were your original. I didn't build these kind of checks into the code, but I think it's a good practice because at the end of the day, you want to know how much you're processing eliminated or added to your data set. So going back to this, this is a Boolean. So whatever is true in here, it's going to pick up whatever's dinner. Okay. And it could be false too. So whatever is false is going to be dropped. Now we could calculate the tip percent, right? By just basically taking the variables and dividing tip by total bill times 100. And we could do histograms here, which I do. Okay. You could also use something called apply, and it's basically using a function on every row. Okay. It's row wise. Okay. If axis was equal to 0, it would go through column wise, and that wouldn't make any sense. Okay. I mean, obviously, it's going to be row wise. It's going to do a calculation each time on these rows. Okay. So that's where the axis is equal to 1 is important. It's something that NumPy uses, and in general, that it's something that you should pretty much have memorized in a certain sense because it speeds up your programming. I mean, like, there's a period of time where I would get tripped up between like remembering axis is equal to 0, axis is equal to 1, but it's extremely helpful um, to have that, to know that. So here we take a histogram of it, right? And we could see, I mean, like if we were to impose a density on this thing, which I didn't, I mean, you could see that there's these outliers as well, right? So, histograms are good at pointing out what's the outlier values. I mean, this is 70% too, so that's a lot. That's a lot of tip to give, especially in this day and age. So moving on, there's something called a pipe operator, and this basically chains a bunch of functions to do your data processing. Okay. So if I clean the data here, I've got this DF pipe, and I say, let's filter the party that's greater than or equal to two. So there's got to be two people at dinner or lunch. Then we drop the NA. I mean, obviously, we saw earlier that we don't need to do this, but I'm including it because it's a common issue. And then we assign tip percent, right? So we add a tip percent. Okay, so you see these pipe operators, it basically chains. And this is useful because if you know beforehand what needs to be done, you could make your code extremely concise. Okay, I mean, I could have done this with the EDA and it would have been a lot easier, maybe, right? But this makes your code extremely concise, compact, and readable. Okay, there's a clear methodology when you just put all of like your cleaning operations into one cell versus looking cell to cell. So that's pipe operators. Now we've got grouping data, and this is important because we aggregate information in a way that's more valuable. Okay. So if I group data, DF group by day and sex, and then I take the average, right? I use this dot ag to do the actual calculations, right? And then I do tip, average tip is equal to tip, and then I take the mean of that. So the operations are always the second in these parentheses. And we group it, you see it's indexed by day and sex. So Thursday, male, female, Friday, male, female. What was the average tip? What was the average bill? Okay, that's pretty useful information. Um, the average bill was higher for men on Sunday, but the tip was higher for females, which is pretty interesting. We could also group by time. Again, we use this .ag, right? We group by what we want, aggregating it. We're aggregating by time, right? And then we're actually performing the operations, the sums. And we could see here that we've got lunch, dinner, total tip. I mean, the total tip for dinner is way, way higher. And same with the total bill. Okay. So as a restaurateur, you probably want to know this type of information, right? So you could plan accordingly, inventory levels or whatnot, ingredients. So that's useful. How about group by day and sex and how many people there are? So if we do that, we get this. And we could see, I mean, like the numbers aren't that disparate, especially except maybe on Saturdays, right? And Sundays where it's predominantly male. Thursday, Friday, I mean, there's not that big of a difference, but when you get to Saturday, the male patrons jump. versus the female patrons. So group buys also could like answer some business questions, right? So does the size of the party lead to a larger average tip? I mean, this information could be useful, right? Um, Especially for waiters. And you could see that, yes, it does. Okay, so I mean, the size at 6, the mean tip is over $5. Okay. I mean, 4 and 5, there's not a difference, right? I mean, but there is a gradual increase up to 3, and then 4 and 5, it kind of levels up, but then there's a little bit of a jump back to 6. I mean, this is flat, and then boom. So that looks pretty good, intuitive. We're going to move to setting indexes. Um, you can see that this thing here, it's flat. Okay, as before we saw there was like some type of hierarchy here. It was indexed by day and sex. Okay. So these are two different ways of looking at data. Now, if I set it by day time, you can see that it's indexed by day and time, right? I've got Sunday dinner here, Saturday dinner's here, Thursday dinner. Um, this also changes, like when we perform the group by operation, we saw that earlier that it changes the way the data looks. Okay, it's aggregated on a day time level, so that's the unit of observation, right? We're here, we're not sure what the unit of observation is. It's all flat. Okay. Now, if we want to restore that back to the, we want to restore the multi-level index back to its original columns. We just do a reset index here, DF reset. Okay, so it's back to its original format. Now, this is important. This format is actually very important because this is how machine learning models like to take their data. Okay, you're not going to want to use this format. Now we're going to go into some feature engineering that Pandas is pretty good at. We've got something called PD cut. So basically, it bins numbers into categories. Okay, so we got this total bill here, right? We go 0 to 10 is going to be low, 10 to 20 is going to be medium. 20 to 30 is going to be high, 30 to 50 is going to be very high, 50 to 100 is going to be luxury. So, I mean, we could see a couple of these. 21 is high because it falls into this 20-30 bucket, right? 0 to 10 is low, 10 to 20 is medium, 20 to 30, right? Even on the low, even though it's $21.01, right? It's just like $1 above 20, but it's going to fall into that high bucket. I mean, this could be see, it depends on like if we could have had another category called like medium high or whatnot to make this a little bit more granular, right? I mean, because we've got 21, 23, 24 all falling under the same bucket and 29. Um, each marginal dollar amount, it might make a big difference, right? Especially if it's like a low number like $20, right? 21, 22. It goes to 29. There's a difference, I guess, from purely subjective perspective from the restaurateur. Okay. But I mean, like I was mentioning earlier, this is the way you bin it. But again, I could have binned it a little bit. I could have been more granular. And that depends on you. Like, I mean, that's there's some subjectivity. I mean, people think that data analysis is an objective art. It's not. It's there's some subjectivity involved, and it influences the outcome. So you apply a map. Okay, so I do this map lambda x generous if x is greater than 3 for the tip, else standard, generous, right? Standard. It's all greater than 3 is generous. Here's another map example where you can map actually values in a dictionary. Okay, right? So if we've got values from 1 to 6 here, we can map it. This is the size of the party. So if we got 6 people in a party, that we consider that large, 5 people, medium, 4 medium, right? 2, 3 small, 1 solo. Okay. And again, you could have said 3 is medium as well. I mean, this is purely subjective mappings. Um, but for purposes of this exercise, basically I've mapped it to the way I've mapped it. 4 and 5 medium, 6 large. And we see that. Okay, so we're using this function to map to a dictionary, mapping the values to an actual value. Okay, so that's what's being done here. Now we could do something like where we increase the total bill by like 10% each, total bill and tip. And we could use this apply map. It applies something to each element, x times 1.1, and we increase the value by 10%. And it goes row by row. So everything has been changed. If we look at it, we see 1699 101 just to check, 18.69 1.11. So there's going to be times when you're going to want to do string manipulation. And this could be for a number of reasons. I mean, most NLP tech, most NLP applications require string manipulation, so it's important. And Python has some string commands, right? So like we could do an upper where we convert day column to uppercase. We could do capitalize where we capitalize the first letter of sex, where we do female, male, and then we convert day to upper, right? And then we could also do something like string contains Saturday, right? So if this string contains, if the day string contains Saturday, then we set it to true. So we see here that we set it to true here. Saturday, and we set it to true. Okay. This is a easier, I mean, if you create a variable like this, it's easier to filter, I guess. I mean, like it's easier to filter on a Boolean than an actual day. Um, so that might be a possible use case. Now, going back to what I was mentioning earlier, it's important that you reset the index to have it like column wise and not indexed by variables or a hierarchical index for machine learning variables. Okay, so we're using and we're carrying this df reset. that we worked with earlier, okay, where we reset the index. Now there's something else called PD get dummies, okay, for X, and we could bin it, right? So we got the total bill size, bill bin, medium, bill bin high, bill bin very high, bill bin luxury, like we saw this earlier, okay? And then we could set this Y variable, DF reset tip greater than 3. Okay, so it's a 1 if it's greater than 3, else it's 0, right? Basically, it's a Boolean classification. You're going to see this, okay? False, true, true, right? You could send it like where the true is 1, false is 0. Scikit-learn actually does accept this. So you don't have to actually convert the numbers to 0 and 1. You could just keep it at at its Boolean value, true, false. And that's sufficient, which this does. Um, we use train test split. This is something from, oh no. Yeah, I gotta run this. 1 second. So I have to basically run this, and it runs. I got these values, right? It splits it out, the PD get dummies. I want to go back to the PD get dummies. It splits it up. It's true. If it's a medium, it's true. Everything else, it's false. Okay. So it does that for these categories that have been created by PD cut, which we saw earlier. This bill bin here. So that PD get dummies basically splits this out, right? It appends the bill bin low, bill bin medium, and then if it's medium, it'll assign it with a 1, everything else 0. If it's high, these will be assigned 1s, and then everything else will be 0. So that's the idea of PD get dummies. Um, Now I'm going to rerun this. Should work. Yep. I just look at this just to check. Then I run the random forest. Accuracy at 0.67. So main thing is that you make sure that you have the data in this format before you feed it into the machine learning model. Here's a little bit about hierarchical indexing. Again, if we aggregate by sex day and then get the average tip, right? I mean, we saw this earlier. We're going to convert that, okay, to this, where it's indexed by sex and day. You're going to see that, you're going to see this, you know, these variables basically on the upper side of the table, right? You're not going to see this time next to day. I mean, then you know that's how you know it's basically been indexed by two variables. It's a hierarchical index. So I've got this thing called swapped group, and I basically aggregated by sex and day. Okay. So females mostly Friday, Saturday. I mean, this is the tip, the mean tip. Now, this might not make a lot of sense. So we could swap the levels to day and sex if we wanted to look at data from that perspective. And this might make a little bit more sense. It depends on like how you want to look at the data. Okay. But each day here, I could see, okay, a female came in, female party of two, male party of three. It might make more sense looking at data from this perspective. And how you would do that is swap level. Okay. Here's some time series things that are useful. So we've got this data set where we have this hierarchy. Okay, it's store, date, and hour this time that are the index variables and sales. And again, if we reset the index, we turn it into a flat. Now we could swap the levels. Oops. So what I had to do was basically rerun this because once you reset the index, it carries and it needs to when you do swap level, it needs to be on a hierarchical index. Okay, so I did that. Make sure when you do these changes that you record the change that you want. Okay. So here is how I swapped it, store and date, right? It changed from this to this, date, store, hour, from store date. And this might be more useful, right, as of a format than something like this. Okay. I mean, it depends on the way you look at it. If you're looking at on a store level and then they've got different start dates, I mean, you might look at it that way. If you're just looking at it from like a holistic type of perspective, like your calendar year and you're planning for every store, you might look at it from this perspective. So again, I could switch it back. And this is the preferred modeling. This is the preferred format for modeling, machine learning modeling. So that wraps it up. Thank you very much, and hope to see you soon.